Hello, future pharmacist. Welcome to today's GPAT preparation section. I am Vikram and I want to remind you the journey to success may feel challenging, but every step you take brings you closer to your goal. The journey to success may feel challenging, but every step you take brings you closer to your goal. Pharmaceutical engineering is the important subject for GPAT exam and future career. In today's section, we'll break down complex topic into simple topic. So this today's GPAT preparation lecture is a very important and knowledgeable. So let's started this today's lecture. So pharmaceutical engineering is the branch of science that deals with industrial processes in which raw materials are changed or separated into pharmaceutical useful product such as drug and excipient. Pharmaceutical engineering is the branch of pharmaceutical technology which deals with study of various principles involved in unit operation during dosage form manufacturing. So pharmaceutical pharmacy means related to dosage form and engineering, that means technology. So pharmaceutical engineering is the branch of pharmaceutical technology which deals with study of various principles involved in unit operation during dosage form manufacturing. So in that pharmaceutical engineering, so topic is flow of fluid, size reduction, size separation, heat transfer, evaporation, distillation, drying, mixing, filtration, centrifugation, and materials of pharmaceutical plant construction, corrosion and its prevention. So GPAT point of view, flow of fluid, in that the questions will arises types of flow, laminar, turbulent and translational flow. Another manometers. So one by one we'll learn Reynolds number. Flow of fluid means those flow water have to flow, that is the three types of flow: laminar, turbulent and transitional. Laminar means in a straight line. Transitional turbulent means that is a zigzag, and transitional flow means it is a mixed flow. Means starting that is a laminar and last one that is middle in between turbulent. So this is a mixed flow. So Reynolds number, it is a dimensionless number. It is help to calculate flow pattern in different fluid flow, means laminar, turbulent or transitional. So this Reynolds number will determine or which is identified flow of fluid. At low Reynolds number, flow is laminar flow, while at high Reynolds number, flow is turbulent. So Reynolds number is a dimensionless number. Reynolds number have a no unit, is a pure number. Next, measurement of rate of flow of fluid, that is pitot tube, venturimeter, orifice meter. So this is the measurement of rate of flow of fluid, which is equipment used for measurement of flow of fluid, that is pitot tube, orifice meter and venturimeter. You have to remember this. Next, manometer measure the pressure. So there are three types of manometer: simple manometer, differential manometer and inclined manometer. So manometer which is measure pressure. So piezometer, U-tube manometer, single column manometer. Simple manometer which is measure pressure, differential manometer which is measure a very minute difference in pressure, and inclined which is give the accurate result of determination of pressure. So this manometer. Next topic, that is size reduction. So size reduction, particle size in dosage form manufacturing, the unit operation. Size reduction means reducing of size larger into smaller ones. So taking the example of powders, stone. So when we need to break it of that size larger into smaller ones, so size reduction is important. Means what is size reduction? Means this is a larger particle making this simple two particles, that is meant by reduction by applying external forces. Size reduction is a unit operation carried out for reducing the size of larger particle into smaller coarse particles or fine particles or desired size shape with the help of external force. Size reduction process also termed as comminution, diminution or pulverization. Also remember, normally pharmaceutical powders are polydisperse consisting particle of different sizes. Polydisperse powders create considerable difficulties in the production of dosage form. So size reduction is nothing but reducing of size from larger into smaller ones for easy to mixing, easy to transport, or easy to carry. So size reduction process also termed as comminution, diminution or pulverization. These terms also remember. Factors affecting of size reduction. When we need to reduce the size, that times the factors, that is hardness, material structure, abrasiveness, softening temperature, moisture content, stickiness, and materials yielding dust that are harmful to the health. Hardness, when this material have too much hard, that times difficult to the reduce the size. Material structure, abrasiveness means softy materials, that times also difficult to break it out. Softening temperature, moisture content means higher the moisture content, reducing challenges means particle size reduction is difficult to that condition. Stickiness, those materials are highly sticky, that materials cannot be break. So everywhere will carried out size reductions. In pharmaceutical engineering, in that it is utilized for drug, reducing of particle size of drugs, because this is depend upon pharmacological actions. Smaller the particle size, greater the surface area and greater the pharmacological actions. Means particle size smaller, then greater the surface area and greater the pharmacological actions. That is the correlation. So that's why size reduction is important to improve the bioavailability. So in that we learn about size reduction equipment, name of hammer mill, ball mill, fluid energy mill, edge runner mill and end runner mill. So these are the different mill which is used for size reduction: hammer mill, ball mill, fluid energy mill, edge runner mill and end runner mill. So question will ask, what is the principle of hammer mill? So remember, H then I, make a tricks. H then I means impact. Hammer mills work on the principle, that is impact. Next, ball mill, what is the principle of ball mill? Impact and attrition. Fluid energy mill, what is the principle of fluid energy? Impact and attrition. Edge runner mill, crushing and shearing. So identify the difference. Edge and end runner both are crushing and shearing principle. Ball mill and fluid energy mill, impact and attrition. Hammer mill, impact principle only. So look at this diagram. Another difference, that is it is made up from stainless steel. It is made up from metal. Ball mill is made up from metal. Fluid energy mill made up of either soft stainless steel or through ceramics. It is made up of stone. So edge runner mill made up from stone. Or granite. And end runner mill, it is a consist of steel mortar which is fixed to the plate. Uses used to mill. First, hammer mill used for a dry material. Hammer mill easy to set up. Ball mill is suitable for wet and dry grinding process, but ball mill is not suitable for soft and sticky materials, fibrous materials. So also questions will arise, ball mill which is not suitable. Another, fluid energy mill, it has been So another question, that is which mill which generate the heat during the milling. So fluid energy mill is not, it is not produced. Fluid energy mill used to reduce particle size of drugs and antibiotics and vitamins. So question in GPAT point of view, question will be asked, that is what is the principle, what condition not used mill. So you have to remember this. Hammer mill impact, ball mill impact and attrition, fluid energy mill impact and attrition, edge runner mill crushing and shearing, end runner mill, that is crushing and shearing principle. Various equipment used in size reduction, hammer mill principle, that is impact, ball mill impact and attrition, fluid energy mill impact and attrition, edge runner mill and end runner mill, that is a crushing and shearing. Mechanism of size separation, next topic or next chapter, the size separation, separation of size. Separation of size, size separation means separation of size by passing into the sieve. Mechanism of size separation, agitation, oscillation, vibration, gyration, brushing, centrifugal force. So in GPAT point of view, the questions will ask grades of powders and sieve number along with nominal aperture size as per IP. Coarse powder, sieve number 10, moderately coarse powder 22, moderately fine powder 44, fine powder 85, very fine powder 120. So nominal aperture size, sieve number and nominal aperture size 40%. So question may be asked, the fine powder, which is the nominal aperture size? Fine powder, that is 180 micrometer, that is the nominal aperture size. So this type of question will ask. Coarse powder means arranging the sieve. Size separation means separation of size into larger into smaller ones by passing into the sieve. So size separation is helpful for or objective, that is size separation to make a uniform substance. What happens when we reduce the size, that is not get a uniform size, different particles, some particles have large, some particles have small, but in size separation the particle will get a uniform size, and that is helpful for development of tablet or easy to mixing. So that's why the size separation unit operation is important. Or coarse powder, moderately coarse powder, moderately fine powder and very fine powder, you have to remember. So this is university question. Question will be asked in university examination, those who have prepared. Flow of fluid, manometer, Reynolds number, Bernoulli's theorem and its application, energy losses, Venturi, size reduction. So size separation is also known as sieving, sifting, screening. Size separation is process that involves separation of particle desired size from the mixture of various size particles. So simply separation of size of large or different size, varied size to the desired size, those who want to. Size separation equipment used for sieve shaker machine, cyclone separator. So sieve shaker, cyclone separator and air separator. So sieve shaker is a powder drug separated according to its particle size using number of sieve number. Next means coarse to fine sieve will be arranging. Look at the diagram. Upper sieve, that is a coarse, means those sieve have large size, and last below that sieve, that is a smaller sieve size. Coarse to fine, we arrange the sieves and then particle will be putted and the particle will be separate out, that is the sieve shaker machine. Cyclone separator, centrifugal force is used to separate the solid from fluids. An air separator, centrifugal force is used air environment suspended solids separate. So size separation, sieve shaker machine, cyclone separator and air separator. This is used, you have to remember this. Next chapter, that is heat transfer. Heat. First of all, what is meant by heat? It is a form of energy. It is a form of energy that can be transferred from system to another as a result of temperature difference. Change means transfer the heat from one to another. That result in temperature difference means when we passing the heat, one substance get heated and other get lower heated. Temperature difference, when the temperature is difference, and that times it is transfer. Another heat transfer is a dynamic process in which heat is transferred spontaneously from a region of higher temperature to lower temperature. Take the example of water, cool water and hot water. When we adding the hot water in cool water, that times the water is mix such conditions that is equilibrium temperature. Once equilibrium temperature will got, neither heat will be transferred. When we temperature is difference, cool and hot, that times the temperature heat is transfer. Otherwise, heat is not transfer. Means heat transfer simply it is a form of energy that can transfer from higher system to another result of temperature difference. Heat transfer is a dynamic process in which heat is transferred spontaneously from a region of higher temperature to lower temperature one. Next, a heat can transfer into three different modes: conduction, convection, radiation. Conduction, metal. When we taking the example of metal, that time the conduction, heat is transferred from in the conduction. Convection, natural convection and forced convection. And radiation, heat is transferred in the form of electromagnetic radiation. It is transferred in the form of electromagnetic radiation. Sun पासून जे अर्थ पासून light येते, that is meant by radiation. Forced convection, when we force convections mixing utilize. Natural convection, there is no any force applied. So remember, in the heat transfer, heat is transferred from higher temperature to lower temperature, not to the lower temperature to higher temperature. It is transferred from a region of higher temperature to lower temperature. Mechanism of heat transfer: conduction, convection and radiation. Equipment used in heat transfer, that is heat exchanger and heat interchanger. Transferring the heat from higher temperature to lower temperature, and heat interchanger means transferring the heat from one fluid to another without two fluid coming into direct contact with each other. Heat exchanger, transferring the heat from higher temperature to lower temperature, and heat interchanger, transferring the heat from one fluid to another without two fluid coming into direct contact with each other. So this is the heat transfer. Next, evaporation. So evaporation is a unit operation in which large quantity of liquid get evaporated and make a concentrated product by applying heat. Evaporation is the unit operation in which large quantity of liquid get evaporated by applying heat and make a concentrated product. So in that equipment used in evaporation process, that is steam jacketed kettle, or it is also called as evaporating pan, horizontal tube evaporator, vertical tube evaporator. So first we learn about steam jacketed kettle or evaporating pan, heat transfer by conduction and convection mechanism. Conduction and convection. Construction, it is a hemispherical structure consists of pan called as kettle. Hemispherical structure consists of pan called as kettle. It is enveloped with outer pan called a jacket. This is the two pans joined, steam get passed, steam jacketed allowed to condensate, outlet bottom, outlet and collected concentrated product. Solvent kettle, outside that is made up of kettle, condensate, concentrated products. The solution of suspension is placed. How to working of this steam jacketed kettle or evaporating pan? The solution of suspension is placed into the kettle. Steam is allowed to enter through the inlet, which provide heat to the solution, and the condensate lowered through the outlet, and small scale kettle is used. Also, agitation is done manually by stirrer, and the final product is collected from the outlet bottom of the kettle. Uses evaporating pan is suitable for concentrating aqueous extract, thermolevel licorice extract. Advantages: easy to operate, constructed for small and large scale operation. It is a simple, constructed, easy to operate. Maintenance is low. Disadvantages: heat economy is less, not suitable for heat sensitive material due to the long time exposure. Heat sensitive materials means those drugs have heat sensitive, means higher the heat that losses their activity, that substance is not suitable. Horizontal tube evaporator, suitable for viscous solution. Cascar extract. Vertical tube evaporator, used to manufacture of cascar extract, sugars, salt, etc. So question will ask the which pan is made up from, which kettle is made up from, or which is the principle of evaporating pan. The principle, that is conduction and convection. Heat is transferred by conduction and convection mode. Equipment used for evaporation: evaporators with heating medium in jacket, steam jacketed kettle, evaporator with placed horizontally, horizontal tube evaporator, and evaporator with long tube with natural circulation, climbing film evaporator, and evaporator with long tube with forced circulation evaporator, and multiple effect evaporator. So this is the equipment used for evaporation. Climbing film evaporator. Thermoleable substance such as insulin, liver extract, vitamin C can be used. Climbing film evaporator. Okay, so thermoleable means heat sensitive material is not suitable evaporating pan, but climbing film evaporator is utilized for that purpose. Forced circulation evaporator, it is also used for insulin. And multiple effect evaporator used for treatment like chemical, pharmaceutical industry, high purity distillate. So simply evaporation is a unit operation in which large quantity of liquid get evaporated and make a concentrated product. And what is the need to make a concentrated product? To development of drug. So some making of tea, we heating longer duration of time to evaporated a liquid and make it good tea. Means neither too much heating, neither too much less heating, but need a medium heating. So that's make a good products. So the evaporation process also similar, like means manufacturing of dosage form, means syrup preparation, that time also heating is required. Distillation next. Evaporation and distillation, basic difference: evaporation is carried out below the boiling point and distillation is carried out at the boiling point. Distillation is defined as the separation of components of liquid mixture by process involving vaporization and subsequent condensation at another place. Distillation is defined as separation of components of liquid mixture by a process involving vaporization and subsequent condensation at another place. The distillation process involves two steps: converting liquid into the vapor phase and transferring the vapor to another place and recovering the liquid by condensation. The feed liquid is known as distill and the condensed liquid is known as distillate or condensate. Another, the feed liquid is known as distill and the condensed liquid is known as distillate or condensate. So distillation is a unit operation in which involves separation of vaporizable components from multi-component systems and subsequent condensation of vapors. These are the equipment used in distillation. Simple distillation, flash distillation, molecular distillation, isotropic distillation, fractional distillation, distillation under reduced pressure, steam distillation. So one by one we'll discussing. Simple distillation. Liquid boils when its vapor pressure is equal to atmospheric pressure. Simple distillation conducted, it's a boiling point, made up of stainless steel, copper or any other suitable materials. So assembly of simple distillation is made up from stainless steel, copper or any other suitable materials. Uses for preparation of water for injections, volatile and aromatic water, preparation of organic solvent. So last time the GPAT question will ask directly this water for injections, which method, distillation method is prepared. So water for injections is prepared simple distillation method. So you have to remember this also, the question will ask. Flash distillation used for separating components, petroleum industry. Flash distillation is used for petroleum industry. Next, fractional distillation used for separation of miscible liquid. Miscible means oil and water. This is a miscible example. So these are the separation miscible oil and water that fractional distillation is used. Distillation under reduced pressure, to prevent degradation of drugs or active components. So that time this techniques is carried out, distillation under reduced pressure. Steam distillation, separation of immiscible liquid extracting volatile oils, clove, anise, eucalyptus, purification of liquid, aromatic water, etc. So this also important, steam distillation. Steam distillation is used for separation of immiscible liquid extracting volatile oil, clove, anise and eucalyptus, purification of liquid, aromatic water, etc. So this is all about distillation. Next chapter come to the drying. So drying means a complete removal of moisture. So evaporation, in that large quantity of liquid get evaporated. Distillation, vaporizations and subsequent condensation. That process is called as distillation. And drying means it is a complete removal process, removal of moisture. So how to remove of moisture? Drying. So natural dryer, sun dryer is one of the example that drying process. So drying is required for tablet manufacturing, granules drying. So tray dryer work consists of combined with multiple trays on which material to be dried is placed, include heating unit control temperature. Convection, the heat is transferred in the form of convection drying. Working material is to be dried, sprayed, but the trays hot air is circulated through the chamber and removing moisture from the materials and drying it. So looking this diagram, tray dryer, the different trays are placed in the instrument and that powders will dry, used for food, pharmaceutical industry, drying powders but this is a time consuming process. Batch wise energy consuming or more space is required. Next, drum dryer used for drying of liquid slurry materials into the powders. Spray dryer product is thermolayable quantity is dried by large. Next one, that is a mixing. Mixing is a unit operation in which mixing of two different product or two substance, that is called as mixing. The term mix means put together in one mass or gathering it with more or less constituent element among one another. Mixing is defined as a process in which two or more components within a system are converted into one mass mixture. Mixing, manufacturing of dosage form. The mixing process is very important. So manufacturing of syrup, so we need a solvent, water, and another one requires sucrose. Sucrose and water when we that mix each other to form a syrup. So that's why mixing is a important step. Classification: solid mixing, liquid mixing, and immiscible liquid mixing. Free flowing solids, free cone blender, double cone blender, cohesive solid, planetary mixture, sigma blender. Liquid mixing, impeller, propellers, turbines and paddles, and immiscible liquids mixing, homogenizers, emulsifier, Silverson emulsifier. So look at this. Double cone blender, twin cell blender, ribbon blender, sigma blender, planetary mixture. So double cone blender used for homogeneous solid mixture. Twin cell blender used for solid mixing. Ribbon blender used for mixing of solid, weight, solid mass and plastic solid. Next, using weight granulation process in manufacturing of tablets. Sigma blender, you have to remember, sigma blender is used for weight granulation process of manufacturing of tablet, and planetary mixture used for dry blenders, fast for weight granulation. Next one, that is filtration. Filter, separate out of constituent. You heard about ancient time, we used for cloth for water purification. Filtration, filter the substance. Cloth, when we passing the water, that times the small crystal will reach out, and that means filtration. Filtration is a unit operation in which liquid is passes to the porous medium, and that porous medium retain the solids and allow to permit liquid is known as filtration. So filtration is very important for purification of substance. Plate and frame filter is the equipment used for filtration process. Sterile filtrate, pharmaceutical industries. Filter leaf, another used for batch processes. Rotary drum filter, waste treatment. Rotary drum filter is used for waste treatment. So filtration in that questions, I remember this filtration in that. Filtration is used for separation of substance. Next chapter that is important, centrifugation. Centrifugation is nothing but is a unit operation used for separating the constituent present in dispersion with the help of centrifugal force. Centrifugation is a unit operation used for separate the concentrated material suspended in liquid medium, or it is a unit operation used for separating the constituent present in dispersion with the help of centrifugal force. The how to separate centrifugation techniques which is involve the application of centrifugal force. Separate the particles from solution according to their size, shape, density, viscosity, medium and rotor speed. Based upon size, shape, density and viscosity of the medium and rotor speed have to separate out. Next, application of centrifugation. Production of bulk drug, production of biological product, biopharmaceutical analysis of drug, evaluation of suspension and emulsion, determination of molecular weight of colloids. So first application, production of bulk drugs. Separate of crystalline drugs such as aspirin from mother liquori, separate crystal from suspension. Production of bulk drug, production of biological product. Most of the proteinous drug and macromolecules are present as a colloid dispersion in water. Production of biological product, in that most of proteinous drugs and macromolecules are present in colloidal dispersion in water. Insulin can be obtained in pure form by selectively precipitating other fractions of proteins and separated by ultracentrifugation. Separate RBC from blood. So this is one of the application, production of biological product, separation of RBC from blood. Another, biopharmaceutical analysis of drug. Drug present in blood tissue, fluid and urine are normally present in the form of colloidal dispersion. Bioequivalence studies. Evaluation of suspension and emulsion. Determination of molecular weight of colloids by using ultracentrifugation. So these are the applications. Next, classification of centrifugations. Centrifugation are classified based upon mechanism: sedimentation centrifuge and filtration centrifuge. So sedimentation centrifuge and filtration centrifuge. First, sedimentation centrifuge. The example, that is horizontal continuous centrifuge, super centrifuge, conical disc centrifuge and non-perforated basket centrifuge. And filtration centrifuge, semi-continuous centrifuge and perforated basket centrifuge, that is a filtration centrifuge. Sedimentation means settle down the particles due to the high density or high molecular weight. Next, classification based on scale of uses: laboratory use, commercial scale, batch type, semi-continuous, continuous. So have to, this is a perforated basket centrifuge, that is a filtration centrifuge. Filtration centrifuge, difference into the solid and liquid phase, made up of steel. Equipment is made up of steel. Uses: crystalline drugs, sugar crystal, unwanted solids. Sedimentation centrifuge, used for separation of solid. Non-perforated basket centrifuge work from sedimentation centrifuge, they have to settle down. Semi-continuous centrifuge, filtration centrifuge, allowed to rotate ancillary purification of proteins, food industry utilize. Super centrifuge, emulsion in food and pharmaceutical. The first one, that is a perforated basket centrifuge. Perforated basket centrifuge. So this is centrifuge. Basket is mounted above the driving shaft and this is used for batch process. The hold basket is used for hold the materials. Perforated basket centrifuge is a filtration centrifuge. The separation is through perforated wall based on the difference of density of solid and liquid phase. Another, construction, it consists of basket is made up of steel. Another, basket diameter 0.90 meter. Capacity 0.085 meters cube. working of the perforated basket centrifuge, that is the material is kept in the basket when the basket is stationary, means constant, not moving. The amount of material should be optimum, otherwise during the centrifugation it put a great strain on the basket. Another, the loading of material, means putting of material must be done give even distribution. Next, power is applied to rotate the basket, run at 1000 rpm, revolution per minute. The power required for running is small compared to the power required for starting and bring or high full speed. Next, during the centrifugation, the liquid passes through the perforated wall while the solid phase retains in the basket and the liquid leaves the basket and the collected at the outlet. The cake is then dry as much as possible. Sometimes high speed are used to that cake will be completely dried. After a definite period of time, the power is turned off and the material will be removed. Next, perforated basket centrifuge is used for separating of crystalline drugs such as aspirin from mother liquori, removing unwanted solids from liquid. Sugar crystals are separating using perforated basket centrifuge. Next, non-perforated basket centrifuge, you have to work on the principle, that is sedimentation centrifuge. You have to remember. Deposited solid after high resistance to the flow of liquid. Super centrifuge. The question will be maybe asked. Super centrifuge is a sedimentation centrifuge. Separation is based on difference in the densities between two immiscible liquid. Another use of super centrifuge. Super centrifuge is used for separating liquid phases of emulsion in foods and pharmaceuticals. Okay, this is all about in the point of GPAT examination centrifugation. Next topic will turn to the materials of pharmaceutical plant construction, corrosion and its prevention. So many equipment is used for in pharma industry, for pharmaceutical industry. It is made up from iron, steel or etc. Materials for pharmaceutical plant construction, corrosion and its prevention. So first one, what is meant by corrosion? Corrosion is nothing but it is the reaction of metallic material with the environment which cause measurable changes to the materials and can result a functional failure of metals components of complete system. Corrosion means destructions or losses of some parts of metals when a few days after longer duration of corrosion result in complete failure of that system, that machine or that equipment, that is known as corrosion. Types of corrosion: dry corrosion and wet corrosion. Dry corrosion means it involves direct attack of dry gases, air and oxygen on the metals through the chemical reactions. So dry corrosion, absence of moisture. Wet corrosion, it involves attack of aqueous media, water or strong or dilute acid or alkaline metals through electrochemical reactions. So type of corrosion: dry corrosion and wet corrosion. So applications to prevent the problems, corrosion, avoid the corrosions. So need the materials selection, right choice, selection of materials. So corrosion, types of corrosion: another general corrosion, localized corrosion, biological corrosion, etc. Next, how to prevent corrosion? Prevention of corrosion or control of corrosion. Selection of proper material. Selection of proper material, proper design of equipment, coating and lining of materials, altering the environment, using inhibitors, cathodic protections, anodic protections. So selection of proper materials or right materials, this is a very important in industry to avoid the corrosion. Classification of materials used for plant constructions: metals, ferrous metals, non-ferrous metals, non-metals, organic and inorganic. So metals: cast iron, stainless steel, steel carbon, non-ferrous, aluminum, lead, and non-metals, rubber, plastic and glass. So iron have highly corrosive as compared to stainless steel. Stainless steel is a less corrosive. So mainly those equipment which is used for less corrosive. Selection of material. First point, proper materials mean those made from stainless steel. Another, non-ferrous, aluminum, lead is another choice. Rubber, plastic, glass, non-metals. So avoid the corrosion. Remember this classification of materials used for plant constructions. GPAT point of view, the question will ask which is the inorganic materials used for plant constructions or non-metals. Inorganic, the glass is the one of the example. Glass is the inorganic. Then organic, rubber and plastic. Non-ferrous, aluminum, lead. Ferrous, cast irons and stainless steel and carbon. So GPAT point of view, in pharmaceutical engineering, first chapter we learn about flow of fluid, continuous flow of a liquid, that is the flow of fluid. In that we learn about types of flow, means laminar flow, straight line, turbulent flow and both transitional flow. Three types of flow. The predict the flow, which type of flow which predict, that is Reynolds number. Reynolds number is nothing but it is a dimensionless number. It is can identify which type of flow, means laminar, turbulent and transitional. Next we learn about manometer, the measurement of pressure, simple manometer, differential manometer and inclined manometer. Another, pitot tube, venturometer, orifice meter also learn. Bernoulli's theorem, this chapter is also important. Bernoulli's theorem, input is equal to kinetic energy, potential energy and pressure energy is equal. So you have to look on Bernoulli's theorem, also important in first chapter, flow of fluid. Second, size reduction, in that you have to remember different mill, hammer mill, impact, fluid energy mill, impact and attrition principle, fluid energy mill, cutter mill, cutting principle, edge runner mill and end runner mill, crushing and shearing principle. Also there, which mill which is not suitable, which mill will generate the heat. Also this type of question will be asked in size reduction. Size separation, coarse size and fine size, very fine size, shoe shaker, cyclone separator. So this equipments in size separation you have to remember. Then heat transfer, heat is transferred from higher temperature to lower temperature. Mechanism of heat transfer, conduction, convection and radiation. Next, evaporation. Evaporation is heat transfer from higher temperature to lower temperature one. Then mechanism of heat transfer, conduction, convection and radiation. Evaporation, in that you have to remember evaporating pan. Principle of evaporating pan, conduction and convection. Licorice extract, evaporation process used for evaporating pan. Then distillation, simple distillation, water for injection formation. Drying, tray dryer. So each and every equipment may make a chart and you have to remember this. This definitely helpful to your journey of the competitive examination. If you want to more detailed study, you read to the C.V. Subramaniam book as well as Lackman and Alton. So this is a very important to get a detailed informations about, or as well as make the charts or make your keynotes. So that is very helpful for the competitive journey. So I hope this today's lecture is important in competitive examination like GPAT or any other competitive examinations that is arising the questions in the pharmaceutical engineering chapters. Thank you. Keep learning, keep growing, keep supporting.